Hi, Mr. Drinkard. So I'm doing my test corrections for the rotational kinematics quiz. I have quiz A, and I am doing my work on a piece of paper, not on a whiteboard, because I don't have a whiteboard at my house. So, yeah. So the first question is this one right here, question A. So, I realized my mistake is that right here is where I took the average. So instead of taking the average velocity, all I have to do is use the kinematic equation, this one right here, and plug it in. Yeah, I'm gonna do it out. So I'm just gonna write out the equation. Yep. But before I could plug it into the equation, I have to find theta. So to find theta, you just do theta equals S over R. And then S, you know, is 0.66 meters, and R, you know, is 0.1 meters because the diameter is 0.2 and the radius is half of the diameter. So then you get 6.6 radians, and then you do 6.6, so you plug it in. Oh my god. So you plug in with this into this equation. So you do 6.6 equals 0, because you know the initial velocity is 0 because it's not moving, times the time, which is 0.3 plus 1/2 alpha, which is what you're solving for, and 0.33 squared. And then you get, those cancel out because of the 0, and then you get that number times alpha, and then you just divide it out to solve for alpha, and I got 121.21 rad per second squared. So looking back on my test, I realized that I found the average velocity rather than finding the change in velocity, which I kind of made that harder on myself because I ended up not being able to use one of the kinematic equations. But I realize now that I could have just used that kinematic equation and I would have had the answer. So then the next question I have wrong is question 2, which is the one about the tricycle. So I think I slightly overthought this problem. So yeah, what you're solving for is the angular displacement of each wheel. So first I'm going to do the big wheel. And to do this I would do theta equals S over R, which is just the equation that we got in class, but it's, slightly manipulated, so solving for theta. And the S is the arc, like the displacement of the arc, not the rotational displacement. So, and that's given to us in the problem, and it's 30 meters. And the R is the radius of the wheel, and the wheel in this situation has a radius of 0.4 meters, and the answer ends up being 75 rad for the big wheel. And then for the small wheel, you do the same thing, the same equation, theta equals S over R, and you have the same S because they're going the same distance, the same displacement, but the radius is different, and it's 0.15 meters, and I get 200 rad as the answer. And I think that's all I got wrong. Well, I got the extra credit wrong too, but that doesn't matter. So yeah, thank you.